we are moving to the auto transformer. So the auto transformer is a single winding transformer. Another name is single winding transformer. So this particular transformer having only one winding. Okay, so both are connected. Apart from the common transformer, we have a primary winding or secondary winding. Apart from that, it is a single winding. You have a primary as well as some part of the winding act as a primary, remaining part act as a secondary. Okay, no, primary and secondary are not electrically isolated. That means both primary and secondary are electrically connected. See here, both primary and secondary are electrically connected. In case of two winding transformer, it is not like that. Both are electrically isolated. That's what your difference. Next, the working principle, everything is same as two winding transformer, but the difference here, single winding is most efficient and cheaper compared to the two winding transformer. It is also easiest to vary the voltage from primary to secondary voltage. Different voltages you are providing the tappings. Of course, we can provide the tappings for two winding transformer. It is efficiently used in the laboratories. Okay, now I will show you two transformers here. The first transformer, this particular transformer, for example, I will provide here 220 volt, 200 volt, for example. I want to, this is a primary turns. The next secondary is a complete winding. That means it is a step up. For example, it is step up to 440 volts, for example. That means the voltage increases from 200 to 400. Increase the voltage. That is called as a, shown in the figure A is a step up transformer. Okay, coming to here, it is a complete winding is present here. For example, it is a 440 volt. And then here voltage is 200. Let me take the example. So then voltage is decreases. That means it is a step down type. As with each other transformer, the step up or step down ratio depends upon the how many number of turns, primary and secondary. Here primary number of turns, and then complete together it is a secondary number of turns. Based on the primary and secondary number of turns ratio, you can decide whether it is a step up transformer or step down transformer. Clear? Next, we are moving to the, in this particular transformer, how can you use? So in case of audio output stage, automobile radios that can be used as a step down auto transformer. See here, in this case, this is a loudspeaker. In this case, we are using this transformer as a step down transformer. In such a transformer also used as a adjustable transformer for both stepping or stepping down input voltage. See here 220 volt, but here ranges is 300 to 0 volt. If this particular terminal is moving towards 300 volt, it is step up. Whenever it is decreasing less than the 220 volt, it is a step down. That means the output voltage you can adjustable. Either you can use it as a step up transformer or step down transformer. That is a specialty here. It is often used as a light dimmer. In your if you are electrical students or electronic students, in your machine laboratory we have a dimmer starter. We can auto transformer. We can vary the particular knob. What will happen? The vary the voltage to the adjustable voltage. For example, adjustable power to the radio transmitter. We can use this type of transformers. Okay. So this is the auto transformer. So next we are moving to the applications. That is one of the applications is impedance matching. Okay. Of course, we can variable cases laboratories and where we need to require variable voltages where you can use the auto transformer. But intentionally they mention in the syllabus impedance matching. That's what we are going to discuss with impedance matching concept. Let us see what is meant by impedance matching. Maximum power transfer theorem. How it is possible the maximum power transfer from source to load. Whenever load resistance is equal to source resistance. Whenever load resistance is equal to source resistance. But if the AC supply, in place of resistances, we can use load impedance is equal to source impedance. Then only it is possible to transfer the maximum power. So for that reason, how this transformer is used to impedance matching, we will explain here. So for maximum power transfer from one circuit to another circuit should have equal impedances. Just now I mentioned. If do not have equal impedances, transformer suitable turns ratio can be achieved the impedance matching. Got my point? That means with help of the number of turns ratio, we can adjust the impedances equal to the source impedances if it is impedance is not equal. That's why this particular transformer can use also impedance matching from the load impedance to source impedance. In electronic circuitry, it is often become necessary to connect the circuit I output impedance to one of low input impedance. In this case, for example, so I will give the two cases of it is achieve the low input impedance or I input impedance with the help of the step up or step down transformer. Very important. So look at here. For higher for transformer, for example, higher voltage, okay, and lower current, okay. You know, when it is a lower current, more opposition is taking place. More opposition is taking place means that more impedance. So in this particular type of transformer, we can use it as a high impedance matching device. High impedance case. Got my point? Okay. Next, second case. For example, low voltage and high current. Low voltage and high current. How it is possible low voltage and high current? Whenever high current means that it allows the more current means less impedance. So low impedance. Okay, in case of low impedance matching, we can use that particular structure. Got my point? So next, so what is really means that certain certain circuit working at as a high voltage but low input current, it is used as a high impedance. Just now explained. If such circuits are coupled coupled directly, energy transfer will not be maximum. In such case, transformer used as an impedance matching device because its job is to increasing or decreasing the voltage and current efficiently. Okay, that's why we can use this type of transformer for the impedance matching. Now I will take the one example. I will explain how exactly it is happened. Suppose I will take the one circuit output impedance. That means a Z0 or ZL load impedance is 300 ohms. Okay, it is coupled to the circuit of input impedance. For circuit input impedance is 3 ohms. Okay, output is 300 ohms, input is 3 ohms for a particular circuit. So you need to match this 3 ohms to 300 ohms. This 3 ohms to 300 ohms. So how to match with help of the transformer? You know, in the previous lecture I explained impedance referred to primary side, impedance referred to secondary side. All of you just open those pages and then go back to there. Resistance referred to primary side and resistance referred to secondary side. Similar concept here, impedance referred to primary side, impedance referred to secondary side. It is applicable. So 3 ohms, it is a secondary, right? So when viewed from the primary, this 3 ohms is matched with the load. Viewed from the primary, it should be appears as a 300 ohms. Now primary side 3 ohms are divided by 3 by k square transformation ratio. So that means 3 by k square is nothing but is equivalent to 300. From that k is equal to 1 by 10. That means that turns ratio n2 by n1 is equal to 1 by 10. We can apply that, then it is possible to match the impedances. Okay, this is about the impedance matching. With this example you may understand that. Okay, this 3 ohms refer to the primary side of the circuit of the transformer. If you are connected the transformer in between what we call circuit input and output in between, these 3 ohms refer to the primary side. This is a formula 3 by k square, that is n2 by n1 is equal to 1 by 10. Thank you. Okay, next we are moving to the example 4. In this example 4, the primary and secondary voltage of an auto transformer is 500 and 400 volt. See here, it is a 500 volt primary and it is a 400 volt secondary respectively, shown in the diagram. The current distribution in a transformer, so the current distribution in a transformer, if secondary is 100 amperes. Next we are moving to the example 5. A transformer is required to match the 400 ohms output impedance of a transistor power amplifier of 4 ohm speaker. So you know, In this particular case, Z1 value, that is impedance value of Z1 is 400 ohms of your, that is a transformer impedance, as well as Z2 is a speaker impedance, that is a 4 ohms. You need to match the turns ratio. I gave one formula. That formula K is equal to square root of Z2 by Z1 in the previous. Just now I gave the formula. From that formula, what is the Z2 value? Z2 value is 4 and Z1 value is 400. That will be equivalent to square root of 1 by 100. That K is equal to 1 by 10. Is it okay? Once K is equal to 1 by 10, you require turns ratio. Turns ratio K is equal to N2 by N1, that is the turns ratio, is equal to 1 by 10. This is the answer.